Okay, on to doing a play port. Step one, like I said, pop the head off, measure, measure, measure. Lots of measuring. You want to measure your piston at the pin. You want to measure your piston. Of course, you're going to measure the top side of it, but you want to measure your piston here or here at the side, because if you measure here or over here, then of course, it's on a hinge, so it can rock back and forth. You won't get an accurate deck height measurement if you measure the piston on the exhaust side or the transfer side. What you want to do is measure it directly above the pin. It's the same place you take a squish measurement when you shove a chunk of solder in there after you finish your build, to make sure it's not too close. Okay, now pop the head off, measure, 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 find out our squish. This baby, I mocked up the other motor. It's 10 in the hole as well. These things, obviously, like I said, they made them for 30 years, so they evidently they got the tolerances pretty damn tight on the rotating assemblies of these things. They're nice. All the pistons are close, rods, cranks, everything's close from one block to the next. It was still 10 thousandths in the hole. They're all within a thousandth of each other, which is great. Now that I know I'm 10 thousandths in the hole, and I know that I want my squish, technically I want my squish around 40, but I'm not going to get it because my damn gasket's 45 thousandths. Well, uncompressed, I should lose about 6 thousandths, 8 thousandths when I squish it. The reason why I don't know compressed thickness is because my new set of head gaskets is different. It's a different brand, or they're different from the old ones that were on. The old ones were thicker. The old ones are as thick compressed as the new ones are uncompressed. So I expect with 20 foot-pounds on the heads, we're going to lose 6 or 8 thousandths off of there. So that's still going to leave us with 40. So like I said, we're going to mill this all the way down. That's why the guy, the Evinrude tech, told me I could mill 30 thousandths off of here. It's because that damn head gasket's going to provide me all the squish clearance I need. On a Banshee, that doesn't happen. On a Blaster, it does, as long as your piston's down in the hole. Some Blaster jugs are a little shorter than others. Some Blaster rods are a little longer than others. So you can end up with a piston that's proud of the hole, that's actually got a positive deck height instead of a negative one. And with that, you have to be careful. You got to measure, 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 boys. Do your math and do it twice. Measure twice, cut once. You don't want to go buy spare parts for no reason. That's pointless, man. You might as well, if you're gonna have to buy spare parts, shit, hopefully it's because you broke something because you were racing so damn hard. That's okay. You don't want to buy spare parts for no reason or because you fucked up. That ain't no fun at all. We got our measuring done. I showed you how I'm gonna mill this. The lapping process is the same thing, only I'm gonna use 400 instead of 80. Or 40, whatever the hell I was using. You guys, I'd recommend 80 for you guys to do your lapping. It's gonna take a while with 80 grit. It takes a while with 40. I only pulled 5 or 6, maybe 8 thousandths off of this, and by the time my arm was tired, I scrubbed on it for a good 15-20 minutes. My arm was tired, and I only got, like I said, maybe 8 thousandths off of it. I still got quite a bit to go. So there's work yet to go there. I'm not going to make you watch me mill that. It's boring as shit. If I had an editor, I may let I may do that and edit the video so you guys can watch it in fast motion, but it's still stupid to watch me move in fast motion. The only thing fun to watch in fast forward is porn. This thing, I haven't even got started on this yet. I'm not messing with exhaust yet. Like I was telling you earlier, I got this intake nearly done. I want to get in there with some 80 or 120 grit in here, and then come after it maybe with some 180 at the most. You don't need to get your intake that smooth. It's better to have this pathway with a golf ball type surface. It'll actually flow better. Just like golf balls are shaped that way, so they fly farther. So this piece is nearly done. I've got some casting flash and stuff to get rid of in here. This piece is not done yet. I've still got, let's see if I can show you most of the flaws in this. There's some pretty serious, right there. Pretty serious sharp edges and things that jut out into that. I'm going to get rid of that and make it look like, what's going on here? Sorry guys, I got the old block out because I was showing you the carnage on the last video. Let's get the new block out. Now, like I was saying, you saw the sharp edge in the other cylinder. This one's the same way. It's pretty gnarly looking in there. It sticks out pretty far too. Over here, you can see I've done quite a bit of smoothing, but I'm nowhere near done yet. Actually, I'm pretty close to done. I'm gonna hit that with some 80 and maybe 120 after that, and I'm good with that. This poor thing, I've gotten ahead of myself, or gotten in over my head, or whatever you want to call it. It's just like when you start polishing something. You grab the clutch lever off the old dirt bike and think, oh, that's kind of corroded, I think I'll polish that up a little bit. And when you get done with it, it's at a mirror shine. You put it back on your dirt bike or your street bike or whatever, and every other polished piece on the bike looks like crap after you make the one look good. And I get into that. I have that problem every time I start polishing. I have that problem every time I start porting, going beyond where I need to go. So you can see some, you see this line here. It's about 20 thousandths. It sticks up about 20 thousandths right there. And of course I'm going to get rid of that. I'm going to make it look roughly like this. This feels so beautifully smooth here. There's nothing sticking out, and this has been rolled quite well. Nice and smooth, nice and round. Also, I've tapered all of these little, I don't know what you call them, divider thingies, I don't know. Tapered those. Take my thumb and a piece of 80 grit, run around the insides of these holes to ease sharp edges. That'll definitely help there. The air speed right here at the porthole is at fastest in the entire engine. It's at its fastest. So any tiny jut will cause the most detriment to performance. Right here is the worst detriment to performance, is right there at the port. You definitely don't want to fuck that up. I've come in with a file, basically. I've come in with a file both this way. It's my big phone. Come in this way to get some angle on it, and I've also come in this way. The two angles are different though, because I can't get my file to go past that bar right there. And of course this is way too much angle. You know, just bang it into the top side of the port. But it's my favorite port file, damn it, I need it. Oh, there we go. This right here. Boys, let me tell you, this little fucker has made some power. Let me tell you. Did my boy's blaster motor, did my Banshee motor, did the play port on the wife's. This little guy does lots and lots of stuff. I still don't have any of my bent files, and I guess you're not going to see them until I get into porting a different engine, because I don't need them on this. I'm not going to change these port windows. You have to be real careful about port timing on one of these things. What else are we going to do? Also, on the exhaust side, although it's not as important, where this little guy mounts up right here, just like that. See? Two big exhaust ports. Two big exhaust ports. Right here. Wow, that's a lot better on this block. On the other block, this was a big step right here where this edge. I was going to have to come in here, hack the snot out of this and this edge along here, because it was very proud of the surface. Very proud. It's actually even with that one step. Come on, flashlight. My fucking glasses are falling off my face. Boys, it's 9:30, 10 o'clock at night. It's still 90 degrees in this shop. It is hotter than hell. And humid as hell too. My glasses are falling off my face and sweating my ass off. I hope somebody gets something out of this waste of time. Or I hope it's not a waste of time. I shouldn't say that. You can see I've done some easing here on this piece. I don't quite have a square surface anymore. You need to think about the air coming out of here. And when the air has to turn a corner, you need to think about the inside of a corner. Get my handy dandy drawing pad out again. when the air has to go around a corner like this. There's your, okay. Alright, you guys can see that. When your air has to go around a corner, what actually happens, you might as well draw a line right down the center of this pipe. And this is vacuum all in here. This is all vacuum. There's no fucking air molecules there. It's all slammed up against the outside right here. It's all slammed up against the outside wall right there. That's where all your air molecules go. They all have mass. None of them want to change direction. They all slam into that and use it for a guardrail and ride it on around. You need to think about that as your air enters and exits the engine. That's why we're smoothing all these edges, especially if it's on the outside of a corner. If there's a sharp edge right here, then all of a sudden you've just cut your port in half because your air has to go around that sharp edge. And it'll create an eddy current right here. That's why the air won't flow near that. See that circle I made? That's an eddy current. Anytime you have air moving in a straight line and you put something in the way, an eddy current forms behind it. See my other little pipe I made? As air flows through this way, oh son of a bitch. As air flows through in this direction, if this lump is here, it's the back square edge is what causes the eddy current. And an eddy current is just like when you drag an oar through the water when you're rowing a boat, or if you drag your hand, push your hand through the water like this, you'll see two eddy currents form on the right and left sides of your hand as you push it through the water. And it's hydrodynamics. There's nothing you can do about it. It's just the way liquids work. Air is a fluid. Air is a very thin fluid. Water is a medium fluid. Glass is a thick fluid. And fluids